Hey everybody, so you can see that this video is titled Measures of Center versus Measures of Variability, and then I give a little definition of each. So the target for this lesson is to learn the difference between the measures of center and the measures of variability, and then very specifically delve into one measure of variability called mean absolute deviation. All right, so as you can see, I have a couple of definitions here that I got from a site called CK12 Interactive. I'm going to talk about that resource a little bit at the end of the video. Okay, but for now, let's look at their definitions. Okay, so measures of center are also referred to as measures of central tendency. And that's a single number used to describe a set of numeric data. Basically, it describes a typical value within a data set. And you just watched, I'm hoping, a Math Antics video about mean, median, and mode. Mean, median, and mode are three different examples of measures of center. They each tell you something a little bit different, but all of them could be categorized as numbers used to describe a set of numbers, right? So they all give you an idea of about what types of numbers are in the data set, all right? Measures of variability, on the other hand, also called measures of spread, are a single number used to describe the spread, or how far apart the numbers are of a numerical data set. Okay, so for example, if we're talking about the range, that's a measure of variability. Mean absolute deviation is another. We'll be talking about that today. And then another very common one is called the standard deviation, which is something you'll get to in another course. But if you're interested in standard deviation, go ahead and take a look at that on your own. All right, so our focus is going to be on range and mean absolute deviation, and primarily mean absolute deviation. All right, so let's say maybe I have a couple of different math groups that I work with, maybe small math groups. They both have 6 kids in them. And what I do is, let's say I give them an assessment, a formative assessment on, I don't know, maybe percent work or something. And I have the scores listed here. So my purple group is listed on the left and my green group is listed on the right. And I think you can get a real quick sense of how the students did just by looking at them. But let's say I'm looking for more specific information. So let's say I'm looking for a little bit of information about a measure of center and some information about a measure of variability. All right, so let's start with range. All right, so let's say I wanted to know the range of grades in each group, because it would give me some information about maybe things that I could do differently with each group. Basically, range is just the highest number minus the lowest number. Right, so in this group, the highest number is 93, the lowest is 84, so the range is 9. The group on the right very clearly is much more spread out. Their highest grade was a 100, and then the lowest score was a 65. So the range for that group is 35. Right, so these are grades based on a traditional percentage grading. Basically, a traditional percentage grade means it's the number that tells you what percent of the work you got correct. So let's say over here, then I'm looking at this 90 that this student got. That score means they got 90% of the work correct, right? We don't do the traditional grading at this point at middle school, but you'll be doing more traditional grading when you get over to the high school. All right, so anyway, you can see though that clearly, yeah, all right, my green group has a wider range. So my students are spread further apart in terms of their understanding of a particular topic. So I may need to do a little more individualization, where this group maybe seems a little bit more ready to move on. And maybe some people in this group are, right? Okay, now, let's say though I wanted something even more specific, right? The mean absolute deviation is a more specific measure of spread. And the title actually clarifies what it is we're going to be finding. We're going to be finding the mean of the absolute deviations of the numbers. right? So if you just kind of keep that title in mind as we're going through, I think it can help you just a little bit here. So if you're trying to find the mean absolute deviation, the first thing you do is find the mean for each data set. All right, so I've already done the work here, but remember that's adding everything up, dividing by 6 in this case, adding everything up, also dividing by 6 here. So you can see my purple group has a mean of 89.3, green group a mean of 82.3. All right, so that gives me some information there as well, but it doesn't give me information about how far spread apart the grades are. All right, but anyway, that's the first step. Okay, now the second step, you can see I've done a series of subtraction problems here, and I hope you're recognizing the absolute value signs. That's where the word absolute comes in the title here. All right, so here's what we do next. We want to determine how far each data point is from the mean. And we do that by finding the difference and determining its absolute value. So remember, absolute value is the distance that a number is from 0. In this case, absolute value is going to be the distance that a student's grade is from the mean. But since it's a distance, we want to just do an absolute value. We want to get any positive or negative signs out of there, right? Because what we're trying to do is get the average distance that the grade is from the mean. All right, so you can see then for the scores in my first group, my mean was 89.3. So I just went through and subtracted 89.3 from each of those. And then you can see I put absolute value signs around. That's because I want to know the absolute value of each, which just means it's going to be a positive number. Another interesting pattern is note everything in my purple group that was negative has a 3/10 at the end of it. Everything that was positive has a 7/10 at the end of it. If you take a look at the subtraction problems, I think it becomes clear why that's the case. Second group did the same thing, but this time I subtracted 82.3 because that was the mean for this group. Got my differences here. Note it's 3 and 7 again. Very interesting, isn't it? And then I found the absolute value of each. Okay, so that's the second step. And what that does is it tells me for each data point, in this situation, it's grades. It tells me how far each of them is away from the mean. All right, step 3. This is the last step, right? There's really only 3 steps here. You actually find the mean of the deviations, or the absolute value of the differences is what the deviations are. So for example, the 0.7 or the 7/10 here, that is the deviation from the mean for that student. 5 3/10 is the deviation from the mean for that second student. So deviation is another word for difference. All right, so what we're actually going to do now is, and I already did it, is you're actually going to find the mean of all of the deviations. So I added each of these scores up, divided by 6, and I had to round this. I had to actually round for the mean as well. So I just opted to round everything to the nearest tenth. So then that average is 2 9/10. So that's the mean absolute deviation for the first group. I did the same thing for the second group. I just averaged these all together by adding them all up and dividing by 6, and I got 11 7/10. So the mean absolute deviation for the green group is 11 7/10. So I can see that the mean absolute deviation is really almost 4 times greater for the second group than the first group. That again gives me some information that lets me know this second group needs a little bit more work, maybe on more of an individual basis, and maybe I need to do some enrichment activities for some of the top group, some of the top students in that group, where the first group maybe is more ready to move on as a group. So it gives teachers information about their next steps. All right, you guys, that's it. That's how you find the mean absolute deviation. All right, so then if you can see I've added the range to this. So if you look at these 2 pieces of information together, it gives you a really good sense of the variability of that group. If I also decided to find the mean, which I already have, if I also decided to find the median and the mode, that would give me some more information as well. I opted not to do that in this case because I was really focused in this video on measures of variability. All right, so I hope that gives you a good understanding of what mean absolute deviation means. I want to share with you just a couple of works cited here. These are places where I took the information. So this information did come from your Ready book, but I decided to use a couple of other sources instead. So this first one is the CK12. If you're ever looking for any explanations of mathematics online, CK12 is awesome. It's free. They do a great job explaining things. And then, of course, I watched the Khan Academy explanation of mean absolute deviation. I made the example for you on this slideshow just a little more complex than the one on that video. But if you wanted to do a little practice work, you could try Khan Academy. All right, there you have it. Mean absolute deviation, a measure of variability. All right, nice work, everyone.